Hi everyone, welcome to Math is Fun. Today we're going to discuss about Gaussian Elimination. These are the learning objectives for today's lesson. The first one is we're going to review the row operations. The second one explains several requirements to satisfy the row echelon form in a matrix. Next, define a Gaussian elimination. And lastly, perform the Gaussian elimination. This is our problem. Mrs. Santos wants to make the best use of her time and money. She makes gift boxes in 2 sizes to sell during the Christmas season. The material for a small gift box costs 10 pesos, and the material for a large gift box costs 15 pesos. She is determined to make 5 gift boxes per week. She can only spend 60 pesos per week on materials. Write 2 equations to help her find the number of small and large boxes per week that she can make. To answer our problem, let X be the number of small gift boxes that Mrs. Santos can make each week. Let Y be the number of large gift boxes that she can make each week. Thus, 10x is the cost of the material in pesos for the small box, and 15y is the cost of the material in pesos for the large box. In our problem, it is asking us to make 2 equations to find the number of small and large boxes per week that Mrs. Santos can make. So, the first statement that we're going to make into a mathematical equation is the number of boxes Mrs. Santos can make in 1 week is 5. As we equated a while ago that the small box is x and the large box is y, thus x plus y is equal to 5. This is the translation in the statement above. The second statement that we're going to make into a mathematical equation is the total cost Mrs. Santos can spend per week is 60 pesos. So here, it is talking about the cost of the materials used to make a small and large boxes. We equated a while ago that 10x is the cost for the small box and 15y is the cost for the large box, with a total cost of 60 pesos per week. Thus, 10x plus 15y is equal to 60. The 2 equations that form a system of equations described in the problem are x plus y is equal to 5. This is the equation 1. And 10x plus 15y is equal to 60. This is our equation 2. So now we're going to form the matrix of the 2 equations. For our first equation, x plus y is equal to 5. And for the second equation, 10x plus 15y is equal to 60. Okay? We're going to make a matrix. So, in making a matrix, we're going to get the numerical coefficients of the variables. So first is, we're going to get the numerical coefficients of x and y into our first equation. So, here, understood that the numerical coefficient of x is 1 and the numerical coefficient of y is also 1. So, 1, 1. And also, we're going to get the constant 5. Next, our second equation. The numerical coefficient of x is 10. We're going to put it into our matrix, and the numerical coefficient of y is 15 and also the constant 60. So, this is the so-called augmented matrix. What is an augmented matrix? Augmented matrix, it is a shortcut representation of the system of equations. Before we're going to find the solution to the equation given using Gaussian elimination, we're going to review first the row operations. What are the row operations? The first one is the scale operation. It allows multiplying any row of the augmented matrix by a non-zero constant. For example, in this given matrix, our target is to make the second diagonal number, which is 15, into 1. How we can do it? Well, we can use the scale operation. First, get the multiplicative inverse or reciprocal of the given number, which is 15 in this example, to make it into 1. But don't forget to write the notation because we're going to apply it into the items in row 2. So, the multiplicative inverse or reciprocal of 15, which is 1 over 15, we're going to multiply it to row 2, and this is replaces for row 2. So, let's solve. 10 times 1 over 15 is equal to 2/3. 15 times 1 over 15 is equal to 1. And 60 times 1 over 15 is equal to 4. So this is the way how we're going to solve the scale operation. The second one is the pivot operation. It allows adding a multiple of any row to another row, replacing that row. For example, using the same matrix, our target now is to make this number 15 into 0. How we can do it? Alright, we can use the pivot operation. First is we're going to make a notation. So, get the additive inverse of 15, which is negative 15. Then, multiply it to row 1. After that, add it to row 2. And this is replaces for row 2. So, let's solve first for column 1. Negative 15 times 1 is equal to negative 15 plus 10 is equal to negative 5. Next, for row 2, negative 15 times 1 is equal to negative 15 plus 15 is equal to 0. Lastly, negative 15 times 5 is equal to negative 75 plus 60 is equal to negative 15. So this is the way how the pivot operation can be done. And the third one is swap operation. It allows exchanging any two rows of the augmented matrix. For example, still we're going to use the same matrix for our swap operation. How the swap operation can be done? Well, this is so very easy. We're just going to swap row 1 and row 2. So for row 1, we have 10, 15, and 60. For our row 2, we have 1, 1, and 5. For our notation, this is row 1, swap to row 2. We have also some requirements of row echelon. The first one is the leftmost non-zero entry in its row, called the row's leading entry, must be 1. As you can see in this matrix, the main diagonal are all 1. Next, the entries to the right of the leading entry can have any value. Likewise, in the entries above the main diagonal can have any value. Lastly, any rows which contain all zeros must be positioned at the bottom of the matrix below the main diagonal. For the entries below the main diagonal are all zeros. Since we already understand the row operations and the requirements of a row echelon, then let's define what is a Gaussian elimination. Gaussian elimination is also known as row reduction. It is an algorithm for solving systems of linear equations. It consists of a sequence of operations performed on the corresponding matrix of coefficients. Gaussian elimination can be also used to compute the following. The first one is rank of the matrix. The second one is the determinant of a square matrix. And lastly, the inverse of an invertible matrix. Gaussian elimination is named after Carl Friedrich Gauss. He worked in a wide variety of fields in both mathematics and physics, including number theory, algebra, statistics, analysis, differential geometry, geodesy, geophysics, mechanics, electrostatics, astronomy, matrix theory, and optics. Alright, we're going to solve the problem using Gaussian elimination. These two equations, we got them from our problem presented a while ago. And we already formed the matrix for these two equations. This simplified form of the augmented matrix corresponds to a simpler system of equations with the same solutions as the original system. So here, our first pivot number, which is the first number in our diagonal, which is 1. And our target is to make the number below on it into 0. How we're going to make this number 10 into 0? Well, we can use the pivot operation. Get the additive inverse of 10, which is negative 10. Then multiply it to row 1. Then add row 2. And this is replaces for row 2. But before that, we're going to copy first all the entries of our row 1 into our matrix below. So 1, 1, 5. Okay, let's solve the first column. Negative 10 times 1 is equal to negative 10 plus 10 is equal to 0. Negative 10 times 1 is equal to negative 10 plus 15, which is negative 5. Negative 10 times 5 is equal to negative 50 plus 60 is equal to positive 10. Our next target is we're going to make this number in our second diagonal
into 1.
How we can do it? Alright, using the row operations, we can use the scale operation. So get the multiplicative inverse or reciprocal of 5, which is 1 over 5. Then multiply it to root 2, and this is replaces for root 2. So let's solve. Copy first all the entries for our row 1. So 1/5 times 0 is equal to 0. 1/5 times 5 is equal to 1. And 1/5 times 10 is equal to. So our row 2 now, it becomes 0, 1, and 2. So as you can see, in our main diagonal are all 1. And the number below the main diagonal is 0. After we satisfy the requirements in our row echelons, this is the matrix now. So as you can see, the main diagonal are all 1s and the number below the main diagonal is 0. So this column stands for x and the second column stands for y and the last column stands for our constants. So this is our first equation, which is x plus y is equal to 5. And this is also our second equation, y is equal to 2. As you can see, we have the value for y already, which is equal to 2. Our problem now is we're going to get the value of x. How we can get the value of x? It's just so very easy. We're going to substitute the value of y into our first equation, which is x plus y is equal to 5. Okay, so x plus the value of y is equal to 2. This is equal to 5. So we're going to solve for x. How? We're going to eliminate positive 2 to the left side by adding the additive inverse of positive 2, which is negative 2, both sides of the equation. So x is equal to 3. So we have here the value of x, which is 3, and the value of y, which is 2. We're going to check if these two values are correct in our original equation. So x plus y is equal to 5, the value of x is 3, and the value of y is equal to 2. And this is equal to 5. 3 plus 2 is equal to 5. Okay, alright. The equation is balanced. Therefore, the answer to our problem is Mrs. Santos can make 3 small gift boxes and 2 large gift boxes per week. Alright, do you understand already how to find the solution to the linear equations using Gaussian elimination? Okay, this time we have another example using 3 unknowns and 3 equations. So, we're going to form a matrix first. For the first equation, we have 1, 1, 1, 6. For the second equation, 2, 3, 4, 10. And for the last equation, we have 3, negative 4, 5, and negative 30. So, we're going to satisfy all the requirements in our row echelons. So, the number underneath our first pivot number, which is the first number in our diagonal, we're going to make it 0. So, the first number that we're going to make it 0 is this number 2. So, how we can do it? We can use the row operation, which is the pivot operation. So, get the additive inverse of 2, which is negative 2, and multiply it to row 1. Then we're going to add it to row 2. And this is replaces for row 2. But before that, we're going to copy first all the entries from row 1. Okay, 1, 1, 1, 6. Then let's solve for column 1. So negative 2 times 1 is equal to negative 2 plus 2 is equal to 0. Negative 2 times 1 is equal to negative 2 plus 3 is equal to positive 1. Negative 2 times 1 is equal to negative 2 plus 4 is equal to positive 2. Negative 2 times 6 is equal to negative 12 plus 10 is equal to negative 2. Then we're going to copy all the entries from row 3. So we're going to look another problem. And the next problem is we're going to make this number 3 into 0. How we can do it? Still, we can use the pivot operation. So, the additive inverse of 3, which is negative 3, we're going to multiply it to row 1 as our pivot number. Then, we're going to add it to row 3. And this is replaces for row 3. So, we're going to copy the entries from row 1 and row 2. Okay, let's solve column 1 first. So, negative 3 times 1 is equal to negative 3 plus 3 is equal to 0. Negative 3 times 1 is equal to negative 3 plus negative 4 is equal to negative 7. Negative 3 times positive 1 is equal to negative 3 plus 5 is equal to positive 2. Negative 3 times 6 is equal to negative 18 plus negative 32 is equal to negative 50. So, let's look into our new matrix. So, the next problem is we're going to make this number below the second diagonal into 0. Negative 7. How we can do it? Alright, we can use also the 1. This is our pivot number in this matrix. So, we get the additive inverse of negative 7, which is positive 7. And we're going to multiply it to row 2. And we add row 3. And this is replaces for row 3. But before that, we're going to copy first all the entries from our
row 1 and row 2.
So let's solve for row 3, column 1. So 7 times 0 is equal to 0 plus 0 is equal to 0. 7 times 1 is equal to 7 plus negative 7 is equal to 0. 7 times 2 is equal to 14 plus 2 is equal to 16. 7 times negative 2 is negative 14 plus negative 50 is equal to negative 64. Our last problem now is we're going to make this number 16 since this is part of the main diagonal into 1. So how we can do it? We can use the scale operation. So get the multiplicative inverse of 16 or the reciprocal of 16, which is 1 over 16, and multiply it to row 3, and this is replaces for row 3. So copy first all the entries from row 1 and row 2. Then let's solve for row 3. Okay, 1/16 times 0 is equal to 0. 1/16 times 0 is equal to 0. 1/16 times 16 is equal to 1. 1/16 times negative 64 is equal to negative 4. So this is our matrix now. As you can see, all the entries in our main diagonal are all ones, and the numbers below the main diagonal are all zeros. Since we already satisfied the row requirements, then let's find the value of our unknowns. The first column represents for x, the second column represents for y, the third column represents for our z, and the last column is our unknown. So we're going to use the backward substitution. We started from the bottom. Z is equal to -4. So we have here the value of z. Then we're going to make the equation for the second one. So y plus 2z is equal to -2. Since we have already the value of z, then let's solve for y. Y plus 2z is equal to -2, and the value of z is equal to -4. So we're going to solve it. To eliminate -8 from left side, we're going to add the additive inverse of -8, which is +8, both sides of the equation. So y is equal to -2 plus 8 is equal to +6. This is the value for y. We have here already the value for z, which is -4, and the value of y, which is +6. Okay, let's solve for the first equation. S plus y plus z is equal to 6. So, to find the value of x, we're going to substitute the value of y and z. So, the value of y is +6, and the value of z is -4. This is equal to 6. So, let's combine like terms. X plus 6 plus -4, this is equal to +2. Then we're going to eliminate +2 in the left side to find the value of x by adding the additive inverse of +2, which is -2, both sides of the equation to make the equation balance. So x is equal to 6 minus 2 is equal to 4. So we have here the value of x, which is equal to +4, the value of y, which is 6, and the value of z, which is -4. So let's check if this is correct. So x is 4 plus 6 plus the value of z is -4, which is equal to 6. So we're going to combine like terms. 4 plus 6 is equal to 10, minus 4 is equal to 6, which is equal to 6. And as we can see that, the equation is balanced. And the value for x, y, and z are correct. I hope that you understand our lesson for today.